course, with it's Tuesday, so we're doing paper 2. And our first question says, in the diagram, I hope it's big enough and everybody can see, A, it has coordinates -2 and 2, B has coordinates 6 and 5, C has coordinates 0 and -3, and D has coordinates x and y. We don't know the coordinates at D. Are the vertices of a quadrilateral having AD parallel to BC? So first things first, do not make any assumptions. It is not a parallelogram. We only have one pair of opposite sides parallel, and we don't know that these sides are necessarily equal to each other either. So very important, don't make assumptions about what it is in order to help us solve any problems. Second thing, BA produced has an x-intercept at E, all right, so we can see that there on the left-hand side. BD and AC intersect at M, so those are the diagonals of the quadrilateral, and they've told us that N, with the coordinates T and 0, is a point on AD. And we know that T, if they ask us to calculate the value of T, we know that it has to be negative because it's on the negative part of the x-axis. All right, so let's have a look. First couple of questions, calculating gradient, determining the equation of a line, and then we have to solve for t. All right, so 3.1 should be really easy for us. We need to calculate the gradient of line BC. So 3.1, we're going to calculate the gradient of BC, and make sure that you show the people that are marking your work what it is that you're doing. So I'm writing here M to symbolize the gradient, and I'm telling them that I'm calculating the gradient of BC. Okay, so who wants to sub in for me? Who's going to sub into gradient formula for me and tell me what I should be writing here? What should I be writing in the numerator? Have a look at point B and point C. What should go into the numerator?
Come on, Matrix. This is how we learn. You can unmute if you want.
Okay, so Mamelo says -3 minus 5. That's fine for the numerator. Okay, so you've got to be careful in Nhlanhla. What you were saying there would go into the denominator. If you put 6 minus 0 into the numerator, you won't get any marks for subbing in. Remember, it's got to be your change in y over your change in x. Exactly. So if I start at -3, then at the bottom, I've got to have 0 minus 6. Like so. All right, so this question, sorry, I don't have my mouse with me today, which is a bit of a pain in the backside. It's out of 2 marks. So 1 mark for subbing in and 1 mark for our answer. What are you guys getting as an answer? Let's see what you're saying. There we go. Good, everybody. We're getting 4/3 as an answer. And we feel fairly confident that that must be correct because we can see the line has a positive gradient. Okay, so 1 mark for subbing in and 1 mark for the answer. All right, lovely. Let's do question 3.2. Now they want us to determine the equation of AD. Okay, so can anybody tell me how we would do that? What they didn't say, and they probably should have included here, is in the form y equals mx plus c, because after all, AD looks like it is a straight line. So what should we do here? Suggestions, please. Okay, so Nhlanhla says use the gradient of BC. Kalipa, calculate the gradient. Well, the problem with calculating the gradient, of course, is that we don't know the coordinates at D. So what Nhlanhla was saying, Kalipa, is indeed correct. Remember, AD is parallel to BC, and parallel lines have the same gradient. Absolutely. So what am I going to do with that 4/3? I can go and sub it into y equals mx plus c. So I'd end up with y equals 4/3x plus c. What do I need to do now? Sure, Pumzile. Thank you, Nolwazi. That's perfect. Go for it, Pumzile. Unmute and ask.
Ma'am, can you hear me?
Yeah, I can hear you fine. Go for it.
Okay, since AD
Oopsie.
and BC are parallel, don't they have the same gradients?
Yes, they do.
So can we use the gradients of BC as M in AD's equation?
Perfect. 100%. That's exactly right. Okay. And then you've got to sub in another point. So Pumzile, which point would you sub in?
With sub -2 and -2.
And 2.
Yeah.
Perfect. Good. All right. So after subbing in, perfect, Pumzile. Thank you so much. So now we're going to sub in the coordinates at A, -2 and 2. There are a few of you that have said that in order to calculate the value of the y-intercept of line AD. Okay, so y is equal to 2. The gradient 4/3 into -2 plus c. So that means that c is going to be equal to, what are you guys getting as an answer? Good, well done. Okay, you're getting 14/3 as an answer. Quite right, well done. Okay, 14/3 is correct. Let's just, whoopsie daisy, let's just move that down. And they wanted the equation of the line, so let's just put everything together for them. So that would be 4/3x. Don't forget, don't leave the x off. A lot of students are in a hurry in a question like this, and then they leave the x off, and it would actually technically be wrong. Plus 14/3. Perfect. Well done, everybody. Okay, so let's just go up and go and have a look again at the mark allocation. And it should be out of 2, maybe 3 marks. Let's see what they've given us here. Okay, so it's 3 marks. All right. So a mark for using the correct gradient, the same gradient as BC, subbing in that point, and then getting our final answer for C like that. You can do that if you want to, Tuelo, not a problem. You're more than welcome to do that if you want to. Personally, I think that's more work. Myself, I never use that formula, but absolutely nothing wrong with that. You would be marked correct. Obviously, provided you've done the correct thing. Not a problem at all. Okay. All right, good. So now we need to work out the coordinates of T. So let's go and have a look at the diagram. And remember, up at the top over here, they told us that N, the point N with coordinates T and 0, if you remember over here, is a point on AD. So what are they telling us with this piece of information over here? What does it mean that N is? N is the? Yolanda, please just help Nolwazi.
Yes.
They got minus 14/3 for C. Just help them, please. Thank you. Okay, so Pumzile, you're on the right track, but N is the x-intercept. So do we let y equal to 0 and solve for the, did you mean x coordinate? Okay, so you were correct up until you said solve for the y coordinate. So you can let y be 0 and solve for the x coordinate. The x coordinate is the t. Okay, yes, Mbalente, it is the x-intercept of AD. Quite right. Okay, so we would let y be equal to 0. So I'm going to sneak question 3.3 in here. So we would have to take 4/3x plus 14/3 and make that equal to 0. Let y be equal to 0. Okay, so then if I've got 4/3x, it would be equal to negative 14/3. I can drop my denominator because I have the same denominator on both sides. And if 4x was equal to negative 14, it means that x would be negative 14 over 4. And I must remember to simplify. Okay, so that would give me negative 7 over 2. Right, and I was expecting a negative answer because, as we had spoken about before, n is a point on the negative x-axis. Okay. There we go, negative 3.5, absolutely, if you wanted to do it that way as well. Okay, so let's just see what the mark allocations were here. I'll go back down. Okay, so it was only out of 2 marks, which does make sense at matric level. 1 mark for making y 0, and there would be 1 mark on the answer over there. Okay. All right, let's go back and see what the next question is. They want us to calculate in 3.4 the length of AN. Okay, so the length of AN. So what formula are we going to use to calculate the length of AN? We're going to use distance formula, absolutely. It doesn't matter, Lebogang. You can use fractions or you can use decimals. They don't mind. Okay, either will work. All right, not a problem. Yes, correct, guys. Lovely distance formula. So we're going to sub into distance formula. I'm going to squeeze it in over here. So we're calculating the distance of AN, and I want the difference in x squared plus the difference in y squared. So if I start with minus 2, then it would end up being plus 7 over 2 squared. And then as far as my y's are concerned, I'm going to start with 2, and I'm going to say 2 minus 0 squared. Just like that. Sorry, it's a little bit squashed up there. I hope everybody can see what's going on. Whether you use 7 over 2 or 3 over 5, it's not going to matter. All right, so let's work out the distance of AN. What are you guys getting as an answer? Yes, Kalipa, but remember in your formula, it's a minus. So minus minus makes a plus. Yes, me too, Mamelo. Good, well done. And I think this would probably also be out of just 2 marks for using distance formula. Let's just check. Yes, so it is. It's also out of 2. So here you would have 1 mark for subbing into distance formula and 1 mark on your answer, like so. Okay, now the questions start to become a little bit more complicated, but not too bad. All right, question 3.5 says to us, if DC, so line DC, is defined by y equals 3 over 8x minus 3, determine the coordinates of D. So they've given us the equation of this line over here. We know so far that we have the equation of this line over there. All right, well done, Nhlanhla. That's correct. Let's just see if everybody else is going to catch up to you, Nhlanhla. You're welcome to try question 3.6 and 3.7 if you're flying ahead. That's no problem at all. So what method would we use to determine the coordinates of D? Can anybody tell me? So sub NC coordinates into the formula, into which formula, Lebogang? Which formula? If they give you the equation of a line and you have the equation of another line and they want you to find the coordinates of a point on the Cartesian plane and those two lines intersect, what would you do? No, you're not going to let y be equal to 0. That's not going to help you find, because if y is equal to 0, that has to be a point on the x-axis, doesn't it? So D is not a point on the x-axis. There we go, Mbalenhle. Okay, that's it into causal. You need to equate the equations of DC and AD. Good. Yes, Lebogang. That's it. Quite right. Okay, so D represents a point of intersection between AD that we have just worked out the equation of and DC that they gave us. All right, so if they asked for a point of intersection of two lines and you've got the equation of both, then you would solve like that. Okay, so what we're going to have to do in this case is take our equation for AD, which was 4 over 3x plus 14 over 3, and we would need to make that equal to what they gave us, which was 3 over 8x minus 3. So this is linear. So there's only going to be one solution for x and one solution for y. So what we want to do is collect our x's together and collect our number terms together. So I'm going to put 4 over 3x minus 3 over 8x, and I'm going to keep the negative 3 on the left, and I'm going to move the 14 over 3 over. Now, what's the easiest thing for me to do in my equation? I want to get rid of those fractions. I don't want fractions anymore. So what can I do to get rid of the denominators? Can anybody tell me? What can I do to get rid of my denominators here? Okay, but if I times by 3, is it going to help where my denominator was 8? So Lebogang, you're correct. Find an LCD. What would the LCD be? So we've got two denominators that are 3, one denominator that's 8. What would my LCD be? Indeed, intercausal. Perfect. So the easiest thing for me to do is multiply every single term in my equation by my LCD. Okay, so I'm going to multiply this term by 24, this term by 24, this term by 24, and that term by 24. All right, so what ends up happening here, you guys know this well, is that you'd say 3 goes into itself once, it goes in here 8 times 4x would leave me with 32x, and there my denominator is gone. All right, so what would be the value of the second term? What would be the value of the second term? That's it. Well done, Lebogang. So minus 9x. Good. Then the next term is going to be equal to indeed Nolwazi. It's minus 9x. Good, Lebogang. It's going to be equal to negative 72. Lovely. Well done. And the last term is going to be equal to that's it. Minus 112. Okay, does that make sense to everybody? Do you understand what we were doing here, what I was doing here? Are we all okay? Yes. Oh, good. All right. Lovely. Well done, everybody.
Nice, guys.
Good. Well done. All right. And then on the other side, we've got negative 72 minus 112, which gives us negative 184, which we need to divide by 23. And that gives us our x coordinate of negative 8. Okay, so that's what Nhlanhla was saying to us. They said that the x coordinate at D would be negative 8. And of course, if we go back and we look at the diagram, we can see that D is a point in the third quadrant. So we were expecting a negative x and a negative y. How would we work out what the y coordinate is? How would we work out the y coordinate? Exactly. So substitute into either equation. That's it. All right. So either we can use 4 over 3x plus 14 over 3, or we can use 3 over 8x minus 3. I think I'm going to use the second one. So I'm going to say y equals 3 over 8. I'm going to sub in my negative 8 minus 3. And the reason I'm using this one is because then I don't have to pick up a calculator. This would give me minus 3 minus another 3, which would give me minus 6. Okay, so therefore the coordinates at D would be negative 8 and negative 6. Okay, so let's just go and see how many marks that was out of. Sorry, and then I will go back down to that question again. Where am I? I hate not having a mouse. I feel was out of 4. Okay. All right,
Because
so
you
there we
can't
go.
move up and down the way you want.
Yeah, no, it's very irritating. I actually don't know how people just use the pad on their laptop. That irritates the living daylights out of me. I want a mouse. But anyway. Okay, so there has to be a mark for the answer. There has to be a mark for the x. There has to be a mark for the minus 6. So I guess here there would be some kind of mark for accurately simplifying as well. Okay, there we go. Cool. All right. So now let's go and have a look. What are the last couple of questions? Okay, so question 3.6 asks us to prove that ABCD is a parallelogram. Now, this is not something that we've seen since grade 10. Tegofatsa, I don't understand what you mean. What equidistant formula? So you can't assume that AD and DC are equal to one another. Okay, we don't know if they are. So I would say no, you can't do that. So the worst thing that you can ever do with any of these questions is to make assumptions, assuming that things are equal when they're not, et cetera, et cetera. Okay, so no, here they definitely wanted you to do it this way. They wanted you to solve using the equations. All right, if we were told that AD equals DC, then we could perhaps use distance formula, but we can't just use one equation to solve for two different variables. So yeah, I suppose what we could do then, if we knew that AD equals DC, we could work with distance formula and the equation of a straight line, I suppose. But no, they wanted you to use the two equations here, okay, because we don't know that AD equals DC. All right, so now the question becomes, how do we prove that a quadrilateral is a parallelogram? How would we answer this question? What do you guys think? It's just, oh, sorry, I didn't mean to go down. I actually wanted to go to the side. Okay, it's out of 3 marks. How would we prove that ABCD is a parallelogram? Yes, Lebogang, go for it. You're welcome to unmute and speak, Lebogang.
I think they're unmuted. It could be network. Because the Baham, we
Can
cannot
you
hear
hear
you.
me? Whoa.
Now we can hear you.
Yes, we can hear you now.
Oh, okay. Ma'am, would you say that line AD and line BC are parallel, which means they're equal in length?
But hang on a second. Just because lines are parallel, does that automatically make them equal in length?
Wait, ma'am, so we're not using the properties to prove that it's a parallelogram.
No, we are, but what we can't do is we can't say that because two lines are parallel, they're also equal in length. But if what you meant was calculate the length of AD and the length of BC, and then use the fact that one pair of opposite sides is equal and parallel to prove that it's a palm, that's okay.
Oh, okay, ma'am.
Okay, that's all right. Okay, so that would
So
be
then,
one
ma'am,
way.
would you... Oh, sorry, ma'am.
Sorry,
And then, ma'am,
sorry.
would you also say that AC and BD bisect each other?
That is another way of being able to do it. Absolutely. At the moment, we don't know the coordinates of M, and because we don't know that it's a parallelogram yet, we can't do it that way. If you have a look, the next question asks us to calculate the coordinates of M. So
Would
we
you
could use,
the midpoint, ma'am?
you could then, yeah, after you've proved that it's a
Okay.
parallelogram, you could do it then. Yes, absolutely. Absolutely,
Okay, ma'am.
not a problem. All right. So you've got a couple of options here as far as proving it as a parallelogram. If you can prove, as Lebogang was saying, that AD equals BC, you can prove that it's a palm by one pair of opposite sides equal and parallel. Then somebody else in the chat, let me just go back in here, said we need to prove that the gradients of AB and DC are equal to one another. Absolutely, because then you've got two pairs of opposite sides that would be parallel. So that's also fine. Okay, that would be another way that you could do it. Okay, so there'd be more than one way of doing it in this case. Probably easier to work with gradient formula rather than distance formula. Now that we know what the coordinates of DC are, it makes life a whole bunch easier for us. All right, so your options here for question 3.6 is either prove AD equals BC and given AD parallel to BC, therefore ABCD would be a parallelogram because you would have one pair of opposite sides equal and parallel. Or your second option, and Ducourzo suggested, we work out the gradient of AB and DC. So we could calculate the gradient of AB and DC. If equal, we would have two pairs of opposite sides parallel. Okay, and then that means that ABCD would also be a parallelogram. Okay, so either of those two options. Oh, did I make a mistake, Nhlanhla? AB equal to DC. Okay, proving that AB equals DC with the information that we've got wouldn't really help us. Remember, when you want to prove something as a parallelogram, there's 5 ways that you can do it. So it's either one pair of opposite sides equal and parallel, two pairs of opposite sides parallel to one another, that the diagonals bisect, the opposite angles are equal. What's the 5th way? Diagonals bisect. I can't think of it off the top of my head, but there's 5 ways that you can prove. So what I would do here is don't go and create more information and more work for yourself than is necessary. It's only out of 3 marks. So theoretically, we shouldn't be spending more than 4 minutes on this problem. Okay, so I think the easiest thing for us to do here is go with what Ntokozo said and calculate the gradients of AB and DC. Okay, because working with gradient formula is always easier than working with distance. Okay, so I'm just going to write down the coordinates of A. The coordinates of B are 6 and 5. Then we know what the coordinates of D are. Coordinates of D are -8 and -6. And the coordinates of C are 0 and -3. Sorry, please can we mute? Okay, so the first thing that we want to do is we want to calculate the gradient.
Sorry, Teacher Lee, I've muted everyone because I couldn't mute that individual. I
That's
don't know why.
okay. All
Sorry.
right, no problem. It's fine. Thank you very much. So we want to calculate the gradient of AB first of all. Okay, so we would say 5 minus 2 over 6 plus 2. That's going to leave us with 3 over 8. Now we want to calculate the gradient of DC. So this is what I'm getting at. Tell them what you're calculating the gradient of. Okay, especially if it's 2 different gradients in one question, so that the person marking your work can see easily what it is that you're doing. Okay, so we would have -6 plus 3 over -8 plus 0. Why are we getting a different gradient now? That should not be happening. Oh, no, it's not wrong. Okay, sorry, I wasn't looking at the sign of the denominator. So that also gives us 3 over 8. Okay, so what we have here is that the gradient of, what did they give us in the beginning? AD and BC. The gradient of AD equals the gradient of BC given. And the gradient of AB equals the gradient of DC that has been proved above. Therefore, ABCD is a parallelogram. 2 pairs opposite sides are parallel. Okay, and I think that's the quickest, easiest way to answer this question. So here, a mark for the gradient of AB, a mark for the gradient of DC, and then a mark on your reason. Okay, so 2 pairs of opposite sides are parallel. Is everybody okay with that? Do you want me to do it the first way as well, where we worked with distance? Or are we happy with this?
I see everyone says yes. Nantokuze says yes, ma'am. I'm not sure whether it's
Okay.
the
Yes, we're
happiness.
fine, or yes, we want to do it the other way as well.
Mamelo says
I did with
she's
distance,
happy.
but you're happy. Okay, all right. Okay, so you guys are happy. All right, cool. Okay, but yeah, no problem if you do it with distance either. All right, lovely. So that means we're now ready to answer the last question, which was calculate the coordinates of M. Okay, so now we know that it is a parallelogram. Let's put arrows on those lines as well, because now we know they are indeed parallel because their gradients are the same. We need to calculate the coordinates of M. So what formula should we be using here? Yes, good, Kalipa. Lovely. We're going to use midpoint formula, and either we can calculate M as the midpoint of AC, or we could calculate M as the midpoint of BD. Okay, so either or. So what I'm going to do is, just so that it's easier for you guys to see, I'm going to squash question 3.7 in here. So calculating the coordinates at M using midpoint formula, I'm going to do AC. So that would be -2 plus 0 over 2. And then it would be 2 plus -3 over 2. Okay, so the coordinates of M. One thing I think I should have done, sorry, before I got started, I should have put in here, is the diagonals of a palm bisect each other. Therefore, M is the midpoint of AC and BD, because that would be worth 1 mark. Okay, then another mark for going and subbing in, and then a mark on the answer. So that would be -1, and that would be -1 over 2. Okay, and that would be that's it, guys. Well done. And then that would be the last mark over there. All right, so M is the midpoint of AC and BD because the diagonals of a palm bisect. So that's why we're using midpoint formula, and there is our answer. Cool. Any questions before we move on? Everybody happy? Yes, Letabo. So PARM is an abbreviation for the word parallelogram. Cool. All right. So let's go and have a look at this question. I hope this is big enough. Again, I'm kind of struggling without my mouse here to just try and make that a little bit bigger without the thing jumping off the page. And I'm just going to do the same thing over here. Okay, so I wanted to do, let's just see how far we get with this particular question. I can, Leanne. It would be in functions where they would ask you a question like that. So I think I've done things like that with you before, but I don't know if the rest of you can see Leanne's question where she said, will they ask us to find the values of k for which f of x equals k will only have one root? What they are talking about in a situation like that is f of x could be any function, and the line y equals k, it's a simultaneous solution. So if you have, let's say, f of x is a parabola, and then you've got a straight line, where it would only have one solution is if your straight line was a tangent, for example, over here. So either they could get you to do it algebraically, Leanne, where you have to do nature of roots if it was worth a lot of marks, or else they could get you to read the answer off. But when we do functions again, I will try and find a question like that. Okay, for us to do, but it's not an analytical geometry sort of question, strictly speaking. Okay, all right, let's have a look at question 4. It says in the diagram below, the circle centered at M passes through the points C, which has coordinates -1 and 2, and cuts the y-axis at E. The diameter CMD is drawn, and ACB is a tangent to the circle. All right, so the first thing that they want us to do is determine the equation of the circle in the form x minus a squared plus y minus b squared equals r squared. Okay, so we know it is our job to sub in and solve for the a and the b and the r squared. Okay, so they've given us the coordinates at the center. So if they have given us the coordinates at the center of the circle, we can sub in for a and for b. So this would give us x minus 2 squared plus y minus 4 squared equals r squared. We still need to solve for r squared. So now we need another point that lies on the line, lies on the circle, to go and sub in. What point are we going to sub in? Exactly, Kalipa. We're going to sub in point C. So we would sub in C, which has the coordinates -1 and 2. That's an x and a y. So that means that we can solve for r. Okay, so we're going to sub in the x first, -1 minus 2. Sub in the y next. That would be 2 minus 4. And that would give us r squared. Now remember, we don't need to solve for r. We don't need the length of the radius. We're trying to work out the equation of the circle. So we're going to leave it as r squared. So r squared in this case is going to be equal to what? Let's see what you guys are getting. I'm getting a different answer. Maybe I'm going crazy. You guys are all getting 13. Why didn't I get... Oh, sorry, I see my mistake. I put in a 3 instead of a 2. Go. Oh, there we go. All right, I agree. I'm also getting 13 is my answer. All right, so the equation of the circle is x minus 2 squared plus y minus 4 squared equals 13. All right, lovely. So subbing in the correct values for A and B, subbing in for here and getting the correct value on r squared. Nice. Now they want us to write down the coordinates at D. How are we going to do that? Let's try and see if we can squeeze. What can we use to calculate the coordinates at D? How would we do that? Okay, if the question says write down, they're implying that there's not really a calculation involved. Look, it's only out of 2 marks. Okay, fine, fair enough. When you get asked to calculate the length of a line, it's also 2 marks. But here we should be able to do this using a quick and easy method. Let's just see midpoint formula. Yes, Tsegofatso, you could do that. You could use midpoint formula. All right, because CMD is a diameter. Okay, so MC equals MD, right? So yes, you could use midpoint formula. What's the other way that we could do this? So CMD is a straight line. So when we work along a straight line, we could also use translation. Exactly, Mamelo. So we can use translation. So however much we went up and to the right to go from C to M, we could do the same thing to go from M to D. That's going to be the easiest thing for us. So we went from -1 to 2. So that means that we went +3 to the right-hand side. So now we're going to add 3 onto 2. All right, so that coordinate or X coordinate has to be 5. All right, when we went up, we went from 2 to 4. So we went up by 2. So we're going to add 2 onto 4, and that would give us 6. And that's going to be, I think, the quickest and easiest way for us to be able to do it. Does that make sense to everybody? All right, moving on. The equation of AB in the form y equals mx plus c. So remember, AB is a tangent, hint, 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 to the circle. So it's our job to work out the gradient of the tangent, and it's our job to calculate its y-intercept. Yolanda, please will you help Blessing? If you can. All right, so how are we going to work out the equation of AB matrix? How are we going to work out the gradient of that tangent? Okay, so we're going to get the gradient. That's it, Nhlanhla. Good, into causal. Okay, so the gradient of CD times the gradient of AB equals -1. It equals -1 because the radius is perpendicular to the tangent. Okay, so we are supposed to say that. All right, so in question 4.1.3, okay, we have MC perpendicular to AB because the radius is perpendicular to the tangent. That means that the gradient of MC times the gradient of AB will be equal to -1. So the gradient of CD is going to be 4 minus 2 over 2 plus 1. So that's going to give us 2 over 3. So the gradient of AB is going to be equal to -3 over 2. That's it. Good, Mamelo. Find the gradient of CM. Yes. Okay, and now we can go and sub in into y equals mx plus c. So it would be -3 over 2x plus c. Now we need to sub in a point. Okay, and line AB goes through C. So again, we can sub in point C, our coordinates -1 and 2. So 2 will go over here. -1 is going over there. And we can work out the value of C. Okay, so I'm just moving that down a little bit. So what is C going to be equal to? That's it, I'm getting the same thing, a half. Okay, so therefore y will be equal to -3 over 2x plus 1 over 2. All right, so you can see that's out of 5 marks. Okay, so that's 5 easy marks for you guys. That's something that you should be able to do without too much difficulty. What's important here, okay, is knowing that the radius is perpendicular to the tangent, working out what our new gradient is, what our old gradient is, subbing in and getting the equation of the line. Okay. All right, we've only got 10 or so minutes. Let's see what we can get done in this time. What we could always do is come back and do question 4.2 separately, because it is essentially a question in its own right. So I would like to be able to do that with you, but we're going to need a little bit of time to discuss the concepts around that. Let's just see if we can finish off 4.1.4 and 4.1.5 before our time is up. All right, now they want us to calculate the coordinates of E What does E represent? E is the y-intercept of the circle. Okay, so for the y-intercept of anything, we're going to let x be equal to 0. Okay, so using our equation that we calculated in 4.1.1, we're going to make x equal to 0, and we are going to solve for y. Okay, so this would give us 4. And then here, remember, when you square a binomial, it means y minus 4 times y minus 4. Don't forget about that middle term. You can't just square the first term and square the last term. Plus 16 minus 13 equals 0. And that would leave us with y squared minus 8y. 3 plus 4 would leave us with 7. Okay, so the middle term is negative, the last term is positive. So both brackets need to be negative. So either y is 7 or y is equal to 1. Okay, so now we've got to make a choice. What is y going to be equal to? Is it 7 or 1 at E? Okay, it would have to be 7. All right, that would have to be the bigger of the two. All right, so at E, y is equal to 7. So therefore, the coordinates of E would be 7 and 0 and not 1 and 0. Okay, I think everybody is all right with that. That's out of 4 marks. 1 mark for making x equal to 0. There's always a mark on your factors. Let's put a mark over there, and I think it would probably be on both solutions. Over here, remember in the line where you've got your factors are marked all the way. Did I? Oh, thank you. Yes, quite right. Sorry. 0 and 7. Sorry, guys. See what happens when you stop thinking. Sorry, it's a y-intercept, not an x-intercept. Thank you so much. All right, let's try and do the last question. Now they want us in question 4.1.5 to show that EM is parallel to AB. So EM is that line over there. Now that we know that the coordinates over here are 0 and 7, we can calculate the gradient of EM. We already know what the gradient of AB was. Remember, we calculated it over here. And this is another advantage of labeling your work for yourself, because now you don't have to go back and go and dig through everything, because you can see over there, you've worked out what the gradient of AB is. All right. You can use the quadratic formula, Yamkela. You've just got to make sure that you show that you've subbed into it instead of the line with your factors on it. Okay, so just very quickly now, in 4.1.5, we want to calculate the gradient of EM. Okay, so I'm going to do 7 minus 4 over 0 minus 2, and that's going to give me 3 over -2. Okay, so therefore the gradient of AB equals the gradient of EM. Therefore AB is parallel to EM. Okay, all right, so same gradients. That's why the lines are parallel. Okie dokes.